Precise and correctly selected dilution will achieve an accurate analytical result while preventing damage to the analytical instrument. Two concentrated samples can be recognized by strong coloring and high conductivity of the solution. Conductivity generally increases with increasing salinity of the solution, that is, with the amount of dissolved inorganic substances. It is always necessary to think before diluting samples. What results do I need? What results do I expect? What type of analysis is available to me? It is also necessary to consider the experimental conditions, the solution matrix or extraction medium, its composition and concentration, the expected amount of contaminants and other solutes or elements. Let's have a look at the conductivity levels. In general, solutions with conductivity values up to 100 microsiemens per centimeter can be considered as low concentrated, while solutions with values above 1000 microsiemens per centimeter can be considered as very concentrated. For some analytical instruments, a specific conductivitylimit is set for the solutions to be analyzed. For the anion analysis using ionic chromatography, it is 150 microsiemens per centimeter. For the dissolved carbon determination, it is 200 microsiemens per centimeter. Based on the conductivity values, we estimate the so-called dilution factor. For example, if the conductivity is around 1000 microsiemens per centimeter, choose a dilution factor of 10. If the conductivity is around 500 microsiemens per centimeter, choose a dilution factor of 10 or 5, depending on the type of sample and analysis. In order to protect the analytical instrument, a higher dilution factor is preferred. With respect to the detectability of trace amounts, the dilution factor should be chosen with care. How to calculate the amount of sample for a given dilution factor? We need to know the final total volume. Divide the final volume by the dilution factor and the resulting number is the amount of sample in milliliters that we pipette into the tube. For the preparation of 10 milliliters of 10 times diluted solution, we need 1 milliliter of sample and 9 milliliters of dilution liquid. For major and trace elemental analysis using ICP-OES or ICP-MS, we need 10 milliliters of sample acidified with 2% nitric acid. Therefore, we use 2% nitric acid as the diluent. Nitric acid provides preservation of our sample prior to analysis and is a suitable matrix for ICP analysis. For the anion analysis by ion or liquid chromatography and for the dissolved carbon analysis, we use exclusively demineralized water as the dilution liquid. Place the tubes in the rack in continuous rows according to the numbering system printed on the rack, from left to right 1 to 12, rows A to E. Always write down the dilution factor in a pre-prepared sample list.